Hello everyone, I'm Xuxin from Xiaomi Vela. I'm very grateful to be a part of today's online workshop. Today, I would like to share with you the work we have been doing on upgrading NuttX build system to CMake over the past year. As of now, the CMake build system has been in use internally at Xiaomi Vela and has provided a very positive development experience. We have also been updating these features and bug fixes within the community proactively. Okay, let's start this sharing. Today's topic will include following 4 parts. First, I'll give you some background on the build system upgrades. This will include the problems we have encountered when compiling and building before. Afterwards, I will review the evolution of NuttX build system during the upgrade process. This part will include what we have done and provide a simple example to compare the difference from before and after the upgrade. Later, I'll focus on the benefits and value that CMake build bring to our project. I believe these benefits will bring great confidence to our build system. The last part, we will discuss the future work directions and plans. Okay, let's move on to the background. In the feedback collected from the development process, we have identified several key areas where our current build system is falling short. Let me outline these points and their implications. Our first major point of feedback concerns the speed of compilation. Users have found that build execution is slower than what's ideal. This slowdown can significantly impact development efficiency, especially in large projects. Moreover, our system currently lacks robust support for parallel compilation when working with multiple configurations. Another area of concern is the behavior of incremental builds. The feedback indicates that there are anomalies and unexpected in how incremental compile. This can lead to inconsistencies or errors, undermining the reliability of build process and potentially requiring full rebuilds more frequently than should be necessary. The cleanup process for intermediate artifacts has also been identified as an issue. Not fully clean up these intermediate files can lead to potential errors in subsequent builds. Ensuring a cleaning workspace is crucial for the predictable build outcomes. Lastly, the current systems lack the flexibility to compile a single module or target independently. This feature would allow the developers to focus on the specific part of the project they are working on, significantly speeding up the developer test cycle by not having to recompile the entire project for small changes. Addressing these issues is about enhancing the overall developer experience, making our build system more reliable, efficiency. Okay, let's check out how other projects are dealing with these issues. The same problems and requirements are prevalent in various large-scale projects. During the evolution process, most early large-scale projects will choose to switch to more modern build tools and enhance the compilation system. As can be seen from the following table, in the autos field, many projects we are familiar with have experienced the upgrade in their build systems. More modern build tools can help us solve most of the above problems. This also proves that this is a necessary choice for everyone. Next, I will introduce the evolution of NuttX CMake build process. Initially, in 2019, the earliest attempts at CMake build originate from the PX4 community. It is the experience of these pioneers that provide a data support for construction optimization. Then, committer protobits from the NuttX community officially submit a migration pull request to the NuttX system. He optimized the PX4 solution and formed the prototype of the current CMake build base. In 2022, Archer from the Vela team restarted the work on CMake. He refined many CMake modules and made improvements. Over the past year, the NuttX community and the Vela team has worked together to implement more ARC support and app supporting on CMake, enhance the more CMake build features. In the future, we will continue to try more convenience build tool integrations and more product usage. This part is about what we do. We will discuss significant upgrade in our transition from a Makefile-based build system to CMake within NuttX. First, we have greatly enhanced our toolset by encapsulating a host of CMake modules. This mimics the functionality of our original tools, while also providing more convenience and modernized core approach with the build process. Furthermore, we have restructured the build target level. By breaking down applications and libraries into independent CMake targets, we have not only improved the granularity of the build configurations, but also refined control over dependencies. Lastly, we have improved our support for third-party libraries with native CMake scripts. Their integrations into NuttX build system is now more straightforward. Below, I will make a simple example to directly reflect the changes in the CMake build system. That's how we add an application to NuttX using CMake. As we can see, first, in terms of directory structure, we need to add a CMake script, which is a CMake list.txt, to the original application build directory, which is the directory where the Makefile is located. In this simple example, we add a simple hello N-shell built-in application. In the original build system, as shown on the left, we need to follow a template, which starts with include apps make defs and ends with include application.mk. This template will help us supplement the key compilation stages, compilation targets, and various macro settings. We can fill in the present variables, for example, prog name, main source, success. In CMake, we have refined the serif template into a function called NuttX add applications. The usage and prototype of the function are introduced in the CMake module file. It will automatically create a CMake compilation target for us and complete the built-in register. Variables such as success and prog name are replaced by function parameters. As shown on the right, adding an application to a CMake build is reduced to a single function call. We can also wrap CMake macros in our own CMake scripts to further simplify the code. Another example is how to port a library to new CMake build. I have used the simple unit test library CUnit as an example. For external libraries that support CMake scripts themselves, we can port them in 3 different ways. The first way is to treat it as a general external code and use general port method, which is to collect the source files and header files we need, and then call the NuttX add library function in CMake to create a target for the external library, and then fill the source property for the CMake target. Our built-in implementation will link the final application library to the NuttX ELF outcome. The second way is to use CMake module NuttX add external library, which directly adds the CMake script of the external library to the current build context, and reuse its own target and property configurations. At the same time, adding the definitions and include directories compiled by NuttX and achieve the same goal. The last way is use the CMake built-in module external project. We can compile the external library into a static library as a separate compilation process that is completely independent of the current compilation. The current compilation toolchain and the compilation options are passed to this independent compilation process through this module. Finally, the static library product is used by import that target to link to the NuttX ELF file. The choice of which way to use depends on the situation. We need to evaluate the complexity of the external library. Next, I will introduce the benefits of CMake upgrade, which is also the main part. First of all, the most important benefit is the direct improvement of compilation speed. In our test, CMake builds are twice as fast as original build system when using the makefile generator. This speed is even faster when using the Ninja generator. In a complex single configuration scenario in Xiaomi Vela, we use the CMake build to optimize a configuration that takes more than 10 minutes to 3. This will greatly improve the efficiency in CI verification, package, and local development. The second advantage is that now we can support parallel out-of-tree build. This will further improve the compilation speed by using parallel multiple configuration compile on the top of direct compilation acceleration. This will be very useful when using multiple configuration product. At the same time, the compile out-of-tree will ensure that our source tree is not polluted. That's completely solving the disclean residue problem. The third advantage is automatically handling the dependency. Compared to the current weak dependency implementation, the new CMake build will be more reliable for incremental compilation. Fourth, support independent compilation of single module targets. Implement independent verification of single module and import and export of library. The final advantage is excellent cross-platform capabilities and more friendly development experience.
After about introduction, let's plan our future work directions together. In the initial stage, we will continue to improve the currently missing features. CMake current coverage capabilities are still not perfect compared to the original Makefile base. In the next stage, I plan to complete the documentation related to the CMake build. Documentations and guidance are also what we are currently lacking. More investment is needed here. Finally, in the future, we plan to integrate universal build tools to make it easier for users to use. We will achieve these goals in order. Finally, there is a special part. We would like to extend our deepest gratitude to the following individuals for their invaluable contribution and support. Thank you for your code contribution and review support. Your effort has been instrumental in driving the success of our project. Thank you for your dedication and hard work. Thank you all.